All right, this is our second video for section 6.2, and in this video I'm going to start off by looking at how to cube a binomial. If you recall, at the end of the last video we looked at squaring a binomial and how that led us to a formula that can be used. Once I'm done cubing a binomial, I'm going to transition into something called Pascal's triangle and the binomial theorem that can help kind of simplify this process for us, okay? So let's say I have the binomial of a plus b being raised to the third power. Wouldn't that be the same as a plus b times a plus b squared, where this initial a plus b is being raised to the first power, right? So then I could continue to expand this out. I'll leave that as a plus b, and then we know that a plus b to the second power is equivalent to a squared plus 2ab plus b squared. Again, that's where we left off in the last video. So now I have a binomial times a trinomial, and let me use the distributive property here. All right, let's do a times each term of the trinomial, and then b times each term of the trinomial. Okay. A times a squared is going to give me a cubed. A times 2ab will give me 2a squared b. And then a times b squared will give me ab squared. B times a squared would be a squared b. B times 2ab would be 2ab squared. And then b times b squared would give me b cubed. Now notice you have some like terms here. 2a squared b, you can combine that with a squared b, and then same thing with ab squared and 2ab squared. So in the end, this is going to lead us to a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay? And we want to think of this result, which has four terms, we want to think of this like a formula that can be used to cube a binomial. All right? So let's apply it to the binomial of 2x minus y being cubed. All right. I need to take the first term of the binomial, which is 2x, and I need to cube that. Then add that with 3 times the first term of the binomial squared times the second term of the binomial. Then plus 3 times the first term of the binomial times the second term of the binomial squared plus the second term of the binomial cubed. All right, so if I simplify all that, 2x cubed would of course give me 8x cubed. 3 times 2x raised to the second times negative y, that's going to end up giving me negative 12x squared y. 3 times 2x times negative y to the second will give me positive 6xy squared. And then negative y raised to the third power is going to give me negative y cubed. Okay. All right, so again, if you know that formula for a plus b raised to the third power, it can just make things a little bit quicker for us when we're trying to cube the binomial than having to actually follow through with all the distribution. All right. Now, I would say the formula that we gave you for squaring a binomial, so back here, this formula, I think that one is pretty reasonable to memorize. Cubing the binomial, it's a little bit more challenging, all right? This one might be a little challenging to memorize, okay? So that's going to lead us into Pascal's triangle, all right? Pascal's triangle is actually going to help us give us a pattern to memorize raising a binomial to any power, okay? So first, let me just introduce the triangle to you, and then we'll have to see how it can be used to raise a binomial to a power, okay? So um, the Pascal's triangle has multiple rows to it, and the first row is actually considered row 0. So n is representing the row number. So n equals 0 is my top row, and it always begins with a 1 in it, okay? This next row is considered the first row, n equals 1, and it would have values of 1 and 1 in it, okay? Then the row below that would be 1, 2, and 1. The row below that is 1, 3, 3, 1. The row below that is 1, 4, 6, 4, and 1. Okay? So hopefully you can see why we're calling this a triangle. Obviously, the pattern of these numbers is forming a triangular pattern. Notice that the outer numbers of each row are always 1s, and then hopefully you can see how we're obtaining the other numbers within each row. So the 2 here is simply the sum of 1 and 1. The 3 is the sum of 1 and 2. Same thing here. 4 is the sum of 1 and 3. 6 is the sum of 3 and 3. And again, 4 is the sum of 1 and 3. So apply that same pattern to give me another row. Would be 1, 5, 10, 5, I'm sorry, 10 again, 5, and 1. And I could continue this on, for as many rows as I want. All right, this pattern will continually repeat. All right, so that's how you form Pascal's triangle. Okay, now how does that help me with raising to a binomial to a power? Well, we have something referred to as the binomial theorem. Pascal's triangle gives us the coefficients for expanding a binomial of the form a plus b to the power of n. And we can use these coefficients with what's called the binomial theorem to find all terms of the expanded binomial. Okay, so we already looked at the pattern for a plus b to the third power. It's a cubed plus 3a squared b plus 3ab squared plus b cubed, okay? And what we want to notice is that the coefficients from each of these terms are 1, 3, 3, and then 1. And if you go back and you look at Pascal's triangle, it's technically the fourth row, but we consider it n equals 3. Right here are the numbers 1, 3, 3, and 1. Okay, so those values give you the coefficients on your 4 terms when you take a binomial and raise it to the third power. All right, now all of the triangle does is give you the coefficients, and then the binomial theorem helps you understand the powers on the variables of each term. Okay, so notice there's a pattern to the powers on your variables here. In the first term, you have a cubed. In the second term, you have a squared. In the third term, you have a. And then in the final term, you don't have a at all. So see how the powers on a, they keep decreasing. And then notice it's the opposite for the powers on b. In your first term, there is no power of b. In the second term, it's b to the first, then b to the second, and then b to the third. So see how your powers on b are increasing from term to term. The other thing, if you'll notice, is if you look at the degree of each individual term, they all have a degree of 3, right? This has a degree of 3, this has a degree of 3, same here, okay? So based off of that, let's come up with a formula for a plus b to the fourth, all right? If I want a plus b to the fourth, then that means I have to look at, it's like the fifth row where n equals 4. So these give me my coefficients, all right? So that means the first term is going to be 1a to the fourth plus coefficient of 4, a to the third b. Notice how I decreased the power on a and then I brought b into play. Plus, next coefficient should be 6, a to the second, b to the second. Plus, next coefficient should be 4, a to the first, b to the third. And then my final coefficient is always a 1, so this is going to be 1 b to the fourth. Okay, now let's apply it to the pattern to a plus b to the fifth power. Okay, go to Pascal's triangle, and you would need this row right here where n equals 5. So again, the first coefficient is going to be 1, 1a to the fifth, plus your next coefficient would be 5, 5a to the b. Your next coefficient would be 10, 10a to the third, b to the second. Next coefficient is also 10, but now it's going to be a to the second, b to the third. Then we have a coefficient of 5 again. So 5a, b to the fourth. And then finally, we've got our final coefficient is a 1, 1b to the fifth. Okay. All right, now let's just take this a step further, and let's use Pascal's triangle and this binomial theorem to simplify 2x plus 3y raised to the fourth. Okay, so we just reasoned out on the last slide that a plus b raised to the fourth should be equal to a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the fourth. All right, so in the expression 2x plus 3y, think of your a value as 2x and your b value is 3y. Substitute those into this formula. That's going to give you 2x to the fourth plus 4 times 2x to the third times 3y plus 6 times 2x to the second times 3y to the second plus 4 times 2x times 3y cubed plus 3y to the fourth. And then we'll simplify each of those. That's going to lead me to 16x to the fourth plus 96x to the third y plus 216 x squared y squared plus 216 xy cubed plus 81 y to the fourth.